Right. Shall we start then? Shall we start then? Are you busy? Like, do you have a class today? Use the WhatsApp group, okay, to talk. Use the WhatsApp group. I won't look at the live chat. Okay, let's start then. Today, today is the day one of mechanics theory. So we are going to do linear motion, maybe equilibrium of forces, then center of gravity and Newton laws and momentum. Those parts we will do. Then linear motion. I will straight away jump into the topic. I don't like to waste time. Linear motion. Give me 1 minute. Okay. Linear motion. There's no big things here. You need to know only 4 equations, and that's all. 4 questions to do questions. And the graph variations, the graphs, and you need to know the 4 equations, and you need to know how to handle it. It means you are given maybe let's say you are given a toolkit. The toolkit has 4 keys, four tools, and you need to know how to use them to do the question. That's something like that. The first equation is equal ut plus half at square. Take your theory books out, okay? I'm not doing full revision. I'm just telling you the brief summary of every topic and how to solve questions. Then second one, b square is equal to u square plus 2a. Then third one, is equal u plus v over 2 into t. Then next one, s equal to t plus half a square. Then v equal u plus a. You know what is s? S means distance, displacement, right? Displacement. Then u is initial velocity, t is time, acceleration. Then all those things repeat in all others. These are the 4 equations. You should know them. It's worse with physics by a separate MCQ. Arunachal MCQ, blah blah blah. That's another story. Okay. There are 4 equations. These 4 equations, today we will learn how to handle them. Okay. Today we will learn how to handle these 4 equations. Right. I will erase the board. Done. Then next we will look at throwing an apple onto the sky. Number 1, apple to sky. Apple to sky. What does this mean? You take an apple and you put it up. What happens? I take this marker. When I catch this, when I put it up, what happens? It goes up, 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 slows down, then comes to rest, and then fall down with acceleration, which means it will accelerate downwards. I will put this up and I will catch it. Okay? Goes up and comes down. Let's see what happens here. Okay? This is the apple. This is the apple. Doesn't look like apple, so I will put A. Apple, right? Okay. Now I'm going to put this up. It will go up, come down in the same path. But to analyze this, I will not do like that. I will just make it like this. Okay, it doesn't go like this. Okay, it will come up, go up and come down. Just to analyze, I will put this like this, and then let's put like this will go up, then comes to here, then again starting from here and then comes down to here. Okay. Then make initial velocity. Let's say u initial velocity u. Ekana meten deddhi rest. Meten deddhi rest eකට එනවා. If when it comes to here it comes rest, then again starting from rest it will move down. එතකොට velocity එක මොකද? මෙතන velocity එක use the group to text. What's the velocity when it starts to come down from here to downwards? What is the velocity here? What's the velocity there? What's the velocity when it starts to come down? Quick. Maybe I don't get the messages. I'm using WhatsApp. Maybe. Let's see. If not, I'll say the answer. Oh. I just scared to message you something, or I'm not getting the messages. Let's see. 0 meter per second. Then පල්ලෙහාට initial velocity 0. එතකොට එතනින් පල්ලෙහාට අපි ගමු v කියන. Let's not like tell going up and coming down with the same velocity. Okay. Now we will apply equations for this motion. For this motion, you can apply s equal ut plus half ad square. S equal ut plus half ad square. Then what's the displacement? Now I'm going to put this up. It's going to come here, come up to here. What's the height? That's the displacement. Okay. Let's say this one is h. උසකට h උසකට යනවා. එතකොට h මෙතෙන්ට එනවා. Initial velocity එකක් තියෙනවා u කියලා. u කියලා එකක් තියෙනවා. Time එක මෙතනින් නම් මෙතෙන්ට time එක t seconds. Okay. t then ut plus half. What's the acceleration? Is it plus 10 or minus 10? Plus 10 or minus 10? You apply equations of motion upwards. Okay. Then make a පැති දෙකක් තියෙනවා. Equations of motions දාන්න පුළුවන් පැති දෙකක් තියෙනවා. කියන්නේ අර equation of motion පල්ලෙහාට දාන්න පුළුවන්. or equation of motion පල්ලෙහාට දැම්මොත් ඔයාගේ displacement එක negative. Because you are applying the equation of motion downwards and the object is moving upward to the respective position, so the displacement will be negative. But now I'm applying the equation of motion to upward. So if you apply to upward, then you know acceleration is downwards, right? Mg is down, mg is downwards, right? That's the acceleration due to gravity. Gravity is on gravity නැත්තම් මේක උඩ දැම්මම මොකද පිටටම යනවා. It won't stop. Okay, it will go up to the sky. I don't know what will happen. So acceleration is downwards and you apply the equation of motion upward. So there is a negative sign. It is negative. How much is acceleration due to gravity? 9.8, right? 9.8. But I will take it as 10 into time t square. Got it? So plus into minus is minus. H is equal to ut minus half into 10t square. 2 and 10 cancel 5. That's how you apply for that equation. I will take another equation. V equal u plus a t. Make a new for this one. Make a Apple ගෙඩි උඩ යනවා විතරයි view වටේ නැගිටින්න. උඩ ගිහින් නවතිනවා. මේ equation එක දාන්න දෙන්න. හරිද? මේ equation එක දැම්මම මොකද වෙන්නේ? So v equal u plus at. V can one final velocity. So final velocity one we obviously උඩට කියලා නව තියෙනවානේ rest. It comes to at rest. So බිඳුව 0. So initial velocity u. I said that I apply equation of motion upward. So acceleration is downward. So negative. Got it? You got it right? I apply the equation of motion upward, but the acceleration due to gravity is downward. So it's going to be negative 10 time t. So u is equal to 10 t. You don't have to memorize these things, okay? You just can get it. You have common sense. So I will apply another equation. V squared equal u squared plus. How to apply this equation? Same thing. Final velocity 0. Initial velocity u squared. What's acceleration? What's acceleration? I'm applying upwards. Okay. Acceleration negative 2 into 10 into distance h. After easy, right? Nothing mechanics is nothing. Okay, just think like that and work. So the fourth equation is equal u plus v over 2 into t. Really, very rarely, and you don't even need that equation. These three equations are enough. I myself haven't used that equation. Never, I think I haven't used it. Yeah, I haven't used that equation. Only these three equations I use. And let's see now when the apple comes down what happens. Then apple get now apple comes down. Starting from rest. It was a velocity v to apple, okay? Not a ball, apple. 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 Right. Let's apply equations of flow, equations of motion. S equal ut plus half at square. S equal ut plus half at square. Then from here to here, displacement h. So h is equal to initial velocity. Now this initial velocity is 0. So this whole thing will be 0. Acceleration are now look okay. I'm applying equation of motion downwards. Equation of motion downwards because it's going down. Yeah. You don't need to apply to upwards because object is going down. So you apply equations of motion downwards. So half this one negative then into 10 into t square 5t square h equal 5t square. That's all. You understand that thing, right? Like the direction you apply. Let's say somebody is there who is applying upward. S equal ut plus half at square. He is applying upward. Some donkey. S equal ut plus half at square. He is applying upward. Now what? Now the object is going down and that donkey is applying to upward. So what happens? Displacement is negative. So I'm drawing this line. He's applying the equation of motion upward, but the object is going down. So it will be negative height. So initial velocity is 0 plus half into, and he's applying upward. So acceleration is negative into t square plus in minus. Minus h is equal to minus 5t square minus cancel h equal 5t square. Same thing, right? Donkey is also correct. So that's that. First application, apple to sky over. Then we have racing car. A car is going. Now take a paper and write this, okay? I didn't give time to that. You can go back and write it, okay? It's a YouTube video. Right, racing car. What happens now? This is a car. Okay, මේක car එකක් කියන්නේ car ඊට පස්සේ මේක යනවා initial velocity v rest. Now it is going this direction. It has an engine, so it will accelerate. It will accelerate with an acceleration of a, and this distance I will take it as h. Let's take it as s. No, let's take it as, tell me a nice little. Let's take k, and then this one has a velocity v naught. This one has a velocity v naught. So we apply equation of motion is equal ut plus half ad square. Displacement k, initial velocity 0 plus half, then make it an equation. So half acceleration a positive into t square and t square. That's all. Other one, v square equal u square plus 2as. Final velocity v naught, initial velocity 0 plus 2 into a into k, right? That's it. Adi on comma apply and easy, right? It's easy, right? So that's the second application. So now we are going to the most important one, projectile motion. Projectile motion. Let's see projectile motion. Third application, projectile motion. I said you at first, right? You have 4 equations and you have only different applications. You should apply. You have 4 equations. You should apply. First, you should memorize them. Memorize them. Number 1, memorize. Number 2, apply. Number 3, keep applying, practice. That's all. So projectile motion. Let's say there is a cannon like this, and there is a bomb. This bomb is going like this, and bomb. Okay. Let's take now this one, this direction. And what is this? Initial velocity v. Initial velocity v. Let's say he is projecting it at an angle of theta. So this is v cos theta in the horizontal direction, and to upward v sin theta. How is it v sin theta? I know this sounds boring, right? This sounds boring because this is the theory. Like, if you know the theory, then no use of joining, right? But this is easy. Mechanics is easy, and easy නෙවන් ඉතින් බලපන්කො මොනවද තියෙන්නේ මේක බෝඩයක් උඩ දානවා velocity gradient දෙක ගත්තා අර කලින් එකම කරන්න තියෙන්නේ equation ටික දාන්න තියෙන්නේ. Now I took the apple, right? I took the apple and threw up. What happened? It goes up, comes the rest. Now equations of motion can be applied linearly. What does that mean, linearly? Linearly means we can apply s equal ut plus half at square for this projectile upward and this direction. Something, this one here. Then you can apply it to this direction and to upward. So I will apply first to upward. Then මොකද වෙන්නේ? මේ velocity change වෙන්නේ නැහැ. Why? Because theta doesn't change. Let's take here and let's take here. Why does v cos theta doesn't change? Now the group, okay, you need to stay active in the group. Stay active in the group. Focus, focus. Stay active in the group. Why does v cos theta doesn't change? I v cos theta වෙනස් වෙන්නේ නැත්තේ. කියන්න. හරි. Hurry up. Why does v cos theta doesn't change? ඒ ආසේ ඇඩ්වර්ටයිස් උත් කරනවා. අයියෝ. කවුද? කමන්නේ. Okay, why does v cos theta doesn't change? Private messaging. Are you scared to put in the group? Okay, v cos theta doesn't change because there is no acceleration. There is no acceleration, and v sin theta changes because there is an acceleration mg downwards. Therefore, අර බෝලේ උඩ දාති උඩට ගිහිල්ලා rest එකට එනවනේ. අන්න ඒ වගේ මෙතෙන්ට එද්දි rest වෙනවා. හරි. Now we can apply equations of motion from here to here. From here to here, let's say R1. Distance is R1. So I am applying S equal to v plus half a t squared upwards from here to here. This is t is equal to t1. This is t is equal to 0. Right. Displacement height h. So S and h. Initial velocity v sin theta into time t1. Acceleration negative. Acceleration negative half into 10 t square. Right, that's it. That's how you apply equation of motion from here to here up to rest. Then you can apply to horizontal direction as well. So horizontal direction is equal ut plus half at square. Making okkoma 0 වෙනවා. Why does this become 0? Because acceleration in the horizontal direction, there is no acceleration in the horizontal direction, so it becomes 0. So S is equal to ut. That's all. Right. Now the applications are over. Now the most important part is graphs. They are open amount. ये ग्रुप पे डाल दो प्रश्न ये ओकने हमारे तो बाद में एडवर्टाइजमेंट है डी ब्लॉक सेमिनार फर्स्ट टाइम right. Let's see graphs. What does graphs mean? Graphs තුනයි තියෙන්නේ සිලබස් එකේ එකක් තියෙනවා ST graph ඊට පස්සේ තියෙනවා VT graph ඊට පස්සේ තියෙනවා AT graph ඔය දෙකෙන් වැඩියෙන්ම යූස් වෙන්නේ මේකයි questions වල අහන්නේ මේකයි right. Then let's analyze an object is there at rest. Now this guy is accelerating and coming to here. Let's say v naught, velocity v naught in this direction. The time is t1. Then from here to here, he doesn't accelerate. He goes in uniform velocity. Uniform velocity doesn't accelerate very much. There is no acceleration v naught up to here. Okay. Here to here v naught. Then uniform velocity. Uniform velocity up to here. ඒ කියන්නේ uniform velocity කියන්නේ same velocity. ඒ කියන්නේ වෙනස් වෙන්නේ නැහැ, no acceleration. No acceleration. So what happens? මෙතනින් නම් මෙතන time t1. Time t1. T1. Okay. From here to here time t1, what happens? Starting from rest. Let's say this position is there. Okay, from this position he's moving to one direction, that direction. Now accelerating means he's like this, then he's starting go. The velocity increases with time. The velocity increases and the rate of change of velocity increases. What's rate of change of velocity? Rate of change of velocity is acceleration. So from here to here, velocity increase. Velocity increase with uniform acceleration. So that comes like this. Fair enough. Did you understand? Did you understand that the velocity is increasing with an acceleration a? So the velocity line graph will go like this. Now don't think too much. Don't think too much. Make a ඔළුවේ තියාගන්න මේක accelerate වෙනවා නම් ST graph එක යන්නේ මෙහෙම. ඉච්චර. يعني ඔච්චර නෑ. Like that. What did I say? ඒකිවේ displacement එක වැඩි වෙන වේගي වැඩි වෙනවනේ. Now how to take the gradient of ST graph? Make a gradient. If you do maths, you know that. Even bio people know this. This is the gradient, and the gradient. What happens to the gradient? Gradient keeps on increasing. The gradient keeps on increasing means the velocity is increasing, and the acceleration is constant. Okay, acceleration is constant. Velocity increasing, and displacement is keeping on increasing. Right. So that's why this from this one to this one it becomes like this. Now what happens if this one is like this? VT graph එක මෙහෙම આવුත් මොකද? මේක මෙහෙම આવුත් මෙතෙන් දෙන්නේ velocity. Now think in your head, okay? Now පටන් ගද්දී t equal 0 නේ object එකක් ගැන හිතන්න. object එකක් ඔළුවට ගන්න. object එකට velocity එකක් තියෙනවා. object එකට velocity එකක් තියෙනවා. මෙතන v කියලා ගමු. object එකේ velocity එක අඩු වෙනවා. හරි. object එකේ velocity එක අඩු වෙනවා. object එකේ velocity එක අඩු වෙනවා කියන්නේ ඔයා දන්නවා rate of displacement එක අඩු වෙන වේගي අඩු වෙනවා. වැඩි වෙන වේගي අඩු වෙනවා. මොකක්ද කියන්නේ? what did I say? මෙතන now we have a velocity, right? Now it will deaccelerate. Now object is there, it will deaccelerate. The velocity is coming to 0 and it comes at rest. Understood? Right. Let's take then deaccelerating. So the gradient should reduce. Something like this. Did you understand? Did you understand? I need the messages in the group, okay? Now you should be active in the group. There are how many members? There are 10. Just put the messages in the group. I want you to stay active. I want you to stay active, man. What are you doing? Sleeping? Okay, whatever. You can watch the link, right? The link will be there in the link will be there in the group. You can watch it. Right? Understood me? When the velocity is reducing, the gradient will go like this. When the velocity is increasing, the gradient will go like this. Right. Are we making it? මේක මොකද ටෙස්ට් එකෙන් යනවා ටෙස්ට් එකෙන් පටන් ගන්නවා v not එක වෙනවා ඇක්සලරේෂන් එකක් එක ඒ කියන්නේ මේක t1 t1 then here increasing acceleration up to here t1 then after that what happens uniform velocity කියන්නේ velocity increase වෙන්නේ නැහැ understood velocity එක වැඩි වෙන්නේ නැහැ කියන්නේ එක velocity කියනවා ඒක velocity angle එක v වල හරි ඊට පස්සේ මෙතෙන් දෙනවා මෙතන මොකද velocity එක change වෙන්නේ නැහැලු velocity එක change වෙන්නේ නැහැ කියන්නේ velocity එක change වෙන්නේ නැහැ කියන්නේ s එක uniformly වෙනවා done. Now acceleration time graph. Easy, that's easy, okay? Accelerating in the positive direction. Then no acceleration. After that, no acceleration. Easy, right? Right. Let's erase that now. Now let's go for a hard one. You're taking a ball and you hit it on the ground. What happens? ගැහුවාම bounce වෙලා උඩට එනවා ඒක එන height එක වැඩි ඊට පස්සේ අඩු වෙලා නැති වෙනවා but let's assume we drop it like this, we drop it, it will bounce and it doesn't come to the initial position, it comes up to something here and again bounce and then after here the energy is lost as heat and some other forms and it doesn't come to the initial position again. So let's say this is u, then this is the ground, bounce වෙනවා වදිනවා bounce වෙනවා u මෙතන v හරි ඊට පස්සේ bounce වෙනවා ආයෙ උඩට එනවා let's say elastic collision elastic collision then let's say v2 then again v accelerating coming to somewhere let's say u2 then I u2 hitting වෙනවා මොහොම ගිහිල්ලා මෙන්න මේ වගේ තැනකට ඇවිල්ලා ඕක නැති වෙනවා මෙහෙම යනවා ආයෙ මෙහෙම යනවා මේක ආයෙ උඩට යනවා පල්ලෙහාට යනවා ආයෙ උඩට හරි මේකට ST graph වෙනවා නෑ VT graph let's go the VT graph VT graph for this motion okay what happens you drop starting velocity 0 again පටන් ගන්නකොට මෙතන be sure නේ පටන් ගන්න මෙතන base එක sorry අතාරිනවා එතකොට අපි let's assume we can assume two things we can assume the point we drop below is positive and above is negative හරි එහෙම ගන්න now let's say the velocity is increasing right velocity වැඩි වෙනවා ඒකල මෙතෙන් වෙනනම් වැඩි වෙනවා ඒකල velocity එක ටක් ගාලා direction එක change කරනවා කියන්නේ දැන් මේ bounce එක උඩට එන්නේ වැඩිලා උඩට එනවා උඩට එද්දී හරිද උඩට එන්නේ velocity එක අඩු වෙනවා. උඩට එවිලා බිඳුව වෙනවා. ඒ කියන්නේ මේක ඉවර වෙනවා මෙතනින්. මේක ඉවර වෙනවා මෙතනින්. මෙතනින් ඉවර වෙනවා නම් මෙහෙම වෙන්න පුළුවන්. දැන් ඒ කියන්නේ because the direction change. This is the positive direction. This is the negative direction. Now I said before I am taking down as positive and up as negative. Now the velocity is upward, so it must be a negative one. So පටන් ගන්න මෙතන. and මේ තරම් මේකට අඩු වෙනවා. Because the energy is lost. Okay. මෙහෙම ඇවිල්ලා මෙතෙන් යනවා. Now what happens? Now it will come to at rest. දැන් මෙතන ඔළුව ඇතුලේ යන්න ඕනේ. කතාව ඔළුව ඇතුලේ යන්න ඕනේ. There's a cracking noise in the movie. Is it okay now? Is it okay now? Is it okay now? How about now? Then now okay. Now okay. I think this is the mic. I remove the mic. Now can you hear me? Hello, can you hear me? Okay, I will continue. Okay, I think you can hear me. I think you can hear me. Okay. So what happens? The velocity changes direction and will again come to zero. With a zero, so it will come to zero, and again the velocity will start to increase. Again the velocity will start to increase, and come to stop. Now why this one is why this one is less than this one? Because the loss of energy. Energy is lost, meaning තේරෙනවනේ ඉතින් ඒක බෝඩයක් අතහැරියාම බෝඩයක් අතහැරියාම බවුන්ස් වෙලා අඩු වෙනවනේ. උත මෙහෙම අඩු වෙලා යනවනේ. ඉතින් අඩු වෙන හින්දා වෙලොසිටි එක අඩු වෙනවා. ආයෙ මෙතන ප්‍රදේශ යනවා මෙතන කඩ ගිරන්නේ නෙමෙයි. Again the velocity will reduce and come like this, come like this, come like this, and it will go. It was saying now. That's how the velocity time graph will go in this one. Right? You need to draw this, right? You don't need it. I will erase it. Right. Now the important one, average velocity. They have given an ST graph. Right? They have given an ST graph. Let's say this one. They have given an ST graph. It's 10 meters and a VT graph. VT graph. 10 meter per second. 10 meter per second. Meter per second. Within seconds. Without a velocity, අඩු වෙනවා. අඩු වෙලා නෙමෙයි. අනේ අපි ගමු යුනිෆෝම් velocity මෙහෙම ගියා. ඊට පස්සේ velocity අඩු වෙනවා. ඊට පස්සේ ආයෙ constant වෙනවා. ආයෙ අඩු වෙනවා. මෙතනින් නවතිනවා කියනකො මෙතනින් නවතිනවා. හරිද? ආයෙ මේකක් ගමුකෝ මෙහෙම කරලා. Let's take like this one. Sorry. From here to here, time is 5 seconds. From here to here, time is 4 seconds. And this is time in seconds. Right? This is time in seconds. This is 0. Now what happens? You know what is the quantity measured on the VT graph? The quantity measured on the VT graph is displacement. Why did I say that? Meter maybe units are in there. Now see again now. Stay in this, don't go out. Okay, I mean don't lose your focus. Stay in this. You can cover this meter per second multiplied by meter per second, because the area on the graph is half. Now these are half into base into height triangle. So this is base into height. So meter per second into seconds. S will cancel off. Meters will come. So the area on the VT graph is displacement. So displacement is 5 into 10. Total displacement equal 5 into 10 plus මෙතන 5 නම් 4 නෙමෙයි 9 seconds. මෙතනින් 5 මෙතනින් 9 නේ නේද? 5න් 4ක් කියන්නේ. ඊට පස්සේ 9න් 5ක් කියනවා 4 plus 4 into half into this height 10. So total displacement නේ මේ ටික ඔක්කොම total displacement. So 2 into 2 then 50 plus how much? 20. That is 70. Now we should find the average velocity. What is the average velocity? Total displacement divided by total time. What's the total time? 9 seconds. Therefore average velocity is 70 megameters. 70 meters divided by 9 seconds. 9 seconds. Whether උත්තරයක් ගන්න. So 9 into 7 63. 7 remains 7.77. Whatever. Average velocity is like that. You take the total displacement under VT graph and you divide by time. That's all. Graphs are again. That's all for graph. How much time? 45 minutes. The graph is complete, I think. We have anything else to discuss now, right? Shall we go to the questions? I'll discuss few questions. Yesterday's question in the graph group, they said one question was there. What's that question you asked? 1993 something? Yeah. This one. 1993 MCQ. The figure shows the velocity time graph for a particle which starts from rest and moves along x direction according to this graph. A statement. The particle comes to rest only at time t is equal to t3. Where is the marker? Marker. Okay. What happens? Velocity time graph is there. T. Like this. This is T1. This is T2. This is T3. Then what they are saying, statement A, this is VT graph. Then statement A, the particle comes to rest only at time t is equal to T3. Okay. Rest. What does it mean by rest? I mean not your resting. Somebody like a vehicle is rest, is at rest means velocity is 0. Now velocity is 0. Method 0. Method 0. Method 0. Without method 0 will be rest. Rest at here, rest at here, rest at here. Done. Statement 1 false. Statement A false. Statement 2. The particle returns to its original position at time t is equal to t3. Original position. Hurry. Now what did I say last time? Average velocity, you have the, I told that this area under VT graph gives you the displacement, right? So what is the area under this one? Make area like a positive. Then මොකද්ද මෙතන එන්නේ? Object එක මේ අනාගත object එක. Now this is the car, okay? Now he is accelerating in this direction. Comes to maximum velocity and again he deaccelerate. මෙතන ඉන්නවා. Accelerate, then deaccelerate. Then what happens? Negative පැත්තට accelerate වෙනවා. එයා rest එකට එනවා. පිටිපස්සට accelerate වෙනවා. මෙතෙන්ට යනවා accelerate වෙනවා. ඒකලා I deaccelerate වෙනවා. Then comes to rest. Now what is, there's a distance between this and this, right? So statement B false. Statement B false. So next statement number 3. The particle accelerates only during the time interval 0 to t1. Eating mega acceleration. Obviously this acceleration. Then what else do you see? This is deceleration. From here to here, deceleration. And this is positive acceleration. Negative acceleration. Mega accelerator. Mega බලන්නේ බිඳුව වෙනවා ගන්න බිඳුව velocity මේක 0 නේ මේක 0 නේ මෙතනින් බිඳුවෙන් එහාට යනවා කියන්නේ accelerate වෙනවා බිඳුවෙන් වැඩි යනවා කියන්නේ accelerate වෙනවා like from 0 if it goes beyond 0 it is acceleration. Now 0 is here. If you go into negative direction there is a positive direction. If this is acceleration then this is also acceleration. Understood? So this one is acceleration and this one is acceleration and this is coming towards 0. Make a wooded coming towards 0. So this one is going to be deceleration and this one is going to be deceleration. This part. Done. I hope you got that question clear. Yesterday someone asked it, that's it. Right. Linear motion finished there. Linear motion finished. I think we'll do the questions in a group about that. Next, we will go into what do we have? Equilibrium. Nothing to there. Nothing is there in that. Equilibrium. Nothing is there. Just you should know how to mark forces, and you need to know how to take moments. No, not moments. Not moments. Equilibrium of forces. Yes, you should know how to take moments also. Right. Let's take a ruler. I don't have a ruler now. I have a ruler. I'm going to balance this. Right? Now what happens here? What happens here? The ruler is, this is the ruler. Okay, this is the ruler, this is my finger. This is the nail, okay, this part. Nail. Then this ruler is there. Where is the center of gravity of the ruler? In the center. If the ruler එක හදපු කෙනා හොඳට හදලා තියෙනවා නම් මේකේ center of gravity තියෙන හරියම නේද? Take a ruler and balance it. So there's 15 centimeters. You will find the balance point at 1.5 centimeters. So center of gravity is here. Downwards mg. That's all the forces. That's all the forces. Now let's put something over this. Now I am going to disturb the equilibrium. I'm going to do that thing and I'm going to disturb the equilibrium. I'm going to keep this. Now it's not balanced, okay? It's going to fall down. See, it fell down, right? So again I'm going to balance it, but now the magic takes place. Now balance, right? What happened? Now what happened? It's balanced, right? Here. What happened? Now what happened? The object is there. Now my finger is not here anymore. Mg is here. My finger is somewhere here. And the object is here. This is mg. This is m1g. Right? This distance is L1. This distance is L2. Right. Now what happened? Right. Total to be in equilibrium. To be in equilibrium. To be in equilibrium, there are two conditions. Total upward forces equal total downward forces. Total upward forces equal total downward forces. And next, the clockwise moments equal anti-clockwise moment. You need to have both these to be in equilibrium. Otherwise, it's not in equilibrium. Now, what did I say? Then I'll erase this. And I will erase this. Total upward force reaction force. The object is, this is the object. This is the, let's say the table. mg තියෙනවා පල්ලෙහාට. mg පල්ලෙහාට තියෙනවා. Make it a reaction force එකක් දෙනවා උඩට. Then every action has an equal and opposite reaction, or equal and opposite. Every action has an equal and opposite reaction. So to the ground, right? Then upward R is equal to mg, that is why it's at rest. So here R is the upward, right? Then here also there is R. That's not R. This R. This is R1. Maybe R1. Okay. Now what? Now there is a R in here. This R1 is equal to R1 in the ruler. Wait. Now this one is going to be very ugly now. I will erase this. I will draw big. Now this is the mass of the ruler acting on the ruler, mg. This is the object, m2g. Because of this one, there is a reaction force downward, R, and every action has equal and opposite reaction force upward, R1. This R is equal to this one. Right, now what? Now I am keeping the finger here. I am keeping the finger here. There is a reaction force upward. Then make a hurry, you should mark the forces correctly. If you don't mark the forces correctly, you can't do it. Take a time and draw this. Take a time and draw this. Right. Now let's mark the forces. Now I'm going to take moments around this position. Let's say this is point O. Then we can say total clockwise moments is equal to total anti-clockwise moments. Now what's the total clockwise moments? Hari mege L1 ne? Mege L1 kiyana? Mege L2 kiyana? L1 L2, okay? Then total clockwise moments are into L1, right? Stay with me. R1 L1, then other side mg L2, then what is R? R kiyanne m2g. R is equal to m2g. m2g into L1 is equal to mgl2. G cancel off. M2 L1 is equal to ml2. This is it. There's a practical for this. Balancing the ruler on the knife edge. There's a practical. So this is it. The basic of equilibrium. Now I will draw another one. Let's say there is a. You should know how to mark forces. Okay. First, you should know how to mark forces. नहीं बारह बजे mg वाले हैं straight down mg. Then there is a reaction force upward. The reaction force is methane R now. මේක කෙලින්ම මෙතෙන්ට R වෙනවා. Right. Is that all? No. I'm going to take friction also. Why did I take friction that side? Let's say this is theta. Then this one is going to come down. If this is theta, then this is going to be theta, right? If this is theta, then this is going to be theta. Hope you got it. Then this direction mg sin theta. I thought you got it, right? The way you take theta here, this is theta, and this it's a, wait, I will draw it clearly. Can't see. Make a 90, make a theta, make a 90 minus theta. Make a 90 minus theta, then this is 90, this is 90 minus theta, then this is 90 minus theta. If this is 90 minus theta, then this is theta. Understood? That's how you take theta. And this is theta. Right. Then what? This is mg. This is theta. Then this side mg sin theta. So reaction force is equal to mg cos theta because it's the main direction mg cos theta. Mg cos theta. Then the reaction force R is equal to mg cos theta. Other than that, the friction. Now friction is trying to resist you. Now when you are studying, you feel something resistant inside. Like your brain doesn't like it. So friction is something like that. If he's trying to move in one direction, friction always tries to resist it. So friction, he's trying to move downward. So the friction is acting upward. Fr. So it's going to be equilibrium. It's going to be in equilibrium because R is equal to mg cos theta and mg sin theta is equal to friction. So friction, you know mu R, right? Now I haven't taught this, but you know it in the theory note. Mu R. Mu R means R is mg cos theta. Friction. Then mg sin theta is equal to friction. Mg sin theta is equal to mu mg cos theta. Mg cancel off. Mu is equal to tan theta. Now no need to memorize this, okay? No need to memorize. No need to memorize. Right. Equilibrium, what else you should know? Let's see the questions. We didn't do strings, eh? Okay, let's see hanging a ruler from a string. How to mark forces? This is the roof, okay? This is the roof, this is the ruler. Then the ruler is going to be mg. Then what's the tension? Let's say the tensions are T1 and this is T2. Then this T1 is for the roller and for the roof also T1 downwards. Got it? So if it's in equilibrium, mg is equal to 2T1. HL. And now what if I say it's not in equilibrium? Make a bar ID. Bar ID will cannot. It cannot. mg is greater than T1. T max means maximum tension. Then it will fall, break and fall down. Then that's all. Then there's another application like this. You take a ruler No, ladder. This is the ladder, and you keep it like this. Now, how to mark forces? How to mark forces? In the center, down mg, right? Downwards mg. Then from this position to upward, there is a reaction force R1. From the wall to this direction, there is R2. What else? Let's say this one is going to fall. It will fall like it won't fall like this. It is going to fall like this. Now friction opposes you. If it's opposing you, there's a friction here. Fr1, and it's going to move in this direction. If it's going to move in this direction, there's a resistive force in this direction, Fr2. That's all. You can take moments around any position here. You can take moments around here and do the question. You can take moments around here and do the question. You can take moments around here also and do the question, because this is in equilibrium. Okay, right. Another point is there is something called stable equilibrium, dynamic equilibrium, and something else is there. I will put a USN for that. I think I have made it in the group, and I will put a USN for that. Small theory parts I will put a USN. What else should we know in equilibrium? I studied. That's all. Yes, so. Now let's go center of gravity. Center of gravity. What does center of gravity mean? Now it's going to be easy. I am taking a book. What is the book I am going to take? And this book is going to. I am taking a book. You balance the book in the hand. Okay. You balance the book in the hand. This is not straight even. The place where you can balance is called the center of gravity. You take an object and you balance it on the finger. That point is the center of gravity. That's all. It's hard to find center of gravity of some object. If I say you to balance this bottle in your hand with one finger, it's hard, because there's water inside and the center of gravity is changing. So it's hard. Now there's an easy way to find center of gravity in an object. Now I am taking this bottle. Okay. And I am hanging it from a thread. Then I am hanging it from the thread. Then I am taking the bottle again. And I am hanging it from somewhere here. Somewhere here it's like this. Like this. Something like this. Then it will go like this. Then කලින් එක කොහොමද මෙහෙමනේ. මෙහෙම හයින් කරලා තියෙද්දි something like this. The place where they meet is the center of gravity. There are MCQs from this. The place where they meet, this line and this line I am combining. Okay, this is the center of gravity. COG. This is the center of gravity. Right. That's how you find center of gravity. Then, what else in center of gravity? Cutting and pasting things. This is the best part. Now you have a circle. Okay, plate-like thing, and its center of gravity is here. You notice in the center of gravity is at the center. This is a uniform plate. Okay. Now what you do is you remove this part. You remove this part. You remove this part and they ask you to find the center of gravity. Is it at position A, B, C, or D? Now obviously, now you have a, I am balancing this marker, okay? If I balance this marker, if I remove the clip, see, the center of gravity has moved to this direction. So when you remove something, the center of gravity shifts to this direction. So this is not D, okay? This is D, A, B, C, D. Okay. Original position here, removing something, then goes to other side. So answer is this one, D. So that's cutting and pasting things. This is the basic one, okay? Basic knowledge. What else in center of gravity? A bomb is going to explode. Not in this house, maybe somewhere. Let's say there is a bomb and it's going to crack and it's going to fall. One piece like this, one piece like this, and another piece somewhere else. Like this. This is the ground, okay? This is the ground, the bomb is at high position. The bomb is going to break and fall. Now, if the bomb doesn't break, if the bomb doesn't blast, it is going to fall like this, okay? If it doesn't blast not, if it blasts this one, this one, this one, if it doesn't blast, it will go like this, right? Now what we can do is there is a method to find the place where the bomb blasted using this one, using the mechanism of center of gravity. How do we do that? Right, let's say this is M1, this is M2, and this is M3, and this is the total mass M1 plus M2 plus M3, right? The same thing in the balancing rule also same thing. Let's say from here you don't know this x dash, and this one is going to be x double dash, and this is going to be x triple dash. So you use the laws of moment to find the location of the center of gravity of the bomb here. Then you apply equations of motion to find this position. They can give an essay question for this. This is the basic theory for that, right? Then the center of gravity basic things are over. Then what's the time? 11:40. Next we have center of gravity, Newton laws of motion. I will do another day. Circular motion, rotational motion, I will do another day. And friction I will do now. Friction I can do now. Friction, there's nothing. There is static friction. Then there is dynamic friction. Dynamic friction, the object is moving. And in static friction, the object is at rest. Right. Now imagine this is an elephant, okay? This is an elephant. Elephant statue, okay? Not real elephant. Elephant statue. This elephant, okay? Elephant. Okay. Not an anteater, elephant. Like this, okay? Now, this is you. I'm going to erase this. This is you. You're pulling a rope here and you're putting it. You're putting it in that direction. So this one is at rest. Now this flow is there, okay? Now when you are trying to pull it in that direction, I say your friction is acting on the other direction. Let's say you are applying 1 Newton first. 1 Newton. Not enough. 1 Newton is not enough. Then you apply 2 Newtons. Not enough. 3 Newtons. Not enough. 4 Newtons. Not enough. 5 Newtons. And it starts to move. Now let's say what we saw. Friction. This is the force and this is the friction force. Okay, this is the force we apply and this is the frictional force. 1 Newton, 2 Newton, 3 Newton, 4 Newton, 4 Newton, 5 Newton. 1 Newton, 2 Newton, 3 Newton, 4 Newton, 5 Newton. What happened? Now as we apply force, this element has a force applied in this direction and equal and opposite force of friction is acting. Equal and opposite force of friction is acting by his legs. Therefore 1 Newton means 1 Newton. Here 1 point is there. 2 Newton means 2 Newton. Here, right? 2 Newton means 2 Newton. Here. 3 Newton means 3 Newton. Here, still not moving. Then 4 Newton, it's on the verge of moving. And 5 Newton is moved. Now I have to tell you a special thing. There is something called coefficient of friction. Now someone in somewhere said friction is directly proportional to the force. What does that mean? Friction is directly proportional to force. You see this, right? When force increases, friction increases. And there was a constant, mu SR. F equal mu FR. Yes, FR is equal to R. This is the F, okay? No, this is R. Reaction force, okay? Right. Mu SR. What does mu S stand for? Mu S means coefficient of static friction. Coefficient of static friction when the object is at rest. Now mu S is acting here. Still the elephant is at rest. Rest. And I told you when 5 Newtons is applied, it's going to move. It's going to move. What happens? There is another coefficient for dynamic friction. That is called mu K. What is that? Mu K. Fr is equal to mu K R. This is coefficient of dynamic friction. This is coefficient of dynamic friction. Now I have to say you one thing. Mu S is greater than mu K. That's it. You have to know this. Mu S is greater than mu K. Which means mu K. Now, what's the equation for friction? Fr is equal to mu R. So, if mu is going to reduce, friction is going to reduce. Sudden drop in friction. What happens? It will go down and then go in constant. This is 5 Newtons. 5 Newtons. From there onwards, it's going to be constant friction, and this guy is applying force. He's going to then apply 6 Newtons, 7 Newtons, 8 Newtons. Doesn't matter. The friction is going to stay constant after a certain maximum friction. This point is called max, Fr max. then it's going to suddenly reduce and then go to concept. You can use a theory note actually. This is not full revision, okay? This is just going through the important points. Right, and this is not a class. Okay, don't misunderstand that this is a class. I'm just telling you the points you need to know to do the MCQs. Right. Then we did linear motion. We did equilibrium of forces. We did center of gravity. We did friction. So I will stop it for now. I think I should stop it for now. And in day 2 we will do the rest of the things. So is there any question or something? No, right? No question, right? So thank you for joining. I don't know how much of them joined today. So I will put the MCQ discussion to the group of Pesuru. Then we will stay with you until the end. Okay. Thank you for joining. Bye bye.